In this experiment, students of Miss A's and Mr. P's class were tested on many of their skills in a program called the Human Benchmark. There are various tests, but we believe that to find which class was mentally stronger in general, we should choose one test from each of the categories. The categories were reaction time, memory, and accuracy. The tests we chose from were the aim trainer for accuracy, reaction time for reaction time, and number memory for memory. These tests work as followed. For the reaction time test, the screen would turn from red to green, and when this happened, the player would have to click. The reaction time would then be showed on screen in milliseconds. For the aim trainer test, the player would have to click different targets on their screen, trying to reach 30 hits as quick as possible, and their time per target would also be measured in milliseconds. Lastly, there was the number memory test, where the player would have to answer and remember a sequence of numbers, and the sequence would get longer with every right answer. And the goal was to type the longest sequence possible. But why would we need this data? We think that this data shows us how well students can perform basic human functions, as well as helping us see who can perform said functions the best. What you see on screen now is a stem and leaf graph, and in the stem and leaf graph, we can see the data from the number memory test for both classes. As shown on the graphs, there are a total of 25 students participating in the Human Benchmark challenges, with 10 of these students being in Mr. P's class and 15 of them being in Mrs. A class. We use the stem and leaf graph to show the general results of the number memory test. This data would be considered continuous because the results were being measured by an application rather than counted by a human. It is helpful to see this data side by side because it helps you view the results in a more organized and neat manner, as well as providing a general idea of which class scored higher. This graph also shows us nearly all of the needed measures, such as the median, range, mode, and the 3 quartiles. So, for these data sets, we can see that Mrs. A class had some higher scores, but Mr. P class was more consistent due to the lower range.
In the aim trainer, targets would show up and students would need to click the target in the fastest time possible. After clicking 30 targets, the average time in milliseconds was calculated. This data showed which class was more accurate. After getting our data, we made a cumulative frequency data graph, and using this graph, we can use the frequency of each score. Our comparison is slightly messed up as Mr. Peacock has 10 students and Miss A had 15 students. Mr. Peacock's class had a consistent score from around 900 to 500, but Miss A's class had a bigger spread due to one outlier who got a score between 100 to 200, compared to the average 600 to 700 scores. Calculating our average for each class shows us that Mr. Peacock's class had an average of 611 milliseconds, while Mrs. A's class had an average of 633 milliseconds. This means overall, Mr. Peacock's class was faster by 22 milliseconds than Miss A's. These two graphs show the data from the reaction speed test for both classes in the form of a box and whiskers graph. Let's start with Mrs. A's class. The class's graph is really skewed to the left because of the outlier of 1.6 thousand milliseconds reaction time. Besides this, we can also see all the quartiles. Quartile 1 being around 200 milliseconds, the median being around 250 milliseconds, and quartile 3 being from 300 to 400 milliseconds. Then we have Mr. P's class. This diagram is far more symmetric due to not having much of an outlier. Then we can once again see all of the quartiles. Quartile 1 being around 220 milliseconds, the median being around 260 milliseconds, and quartile 3 being between 270 and 280 milliseconds. These graphs can also show us the spread of data in each class. Mrs. A class had a range of around 1.5k milliseconds, while Mr. P's class had a range of about 300 milliseconds. This shows us that Mr. P's class was far more consistent than Mrs. A's class. In conclusion, Mr. P's class had a tighter spread of data, a lower minimum score, and a lower maximum score, showing that in general, Mr. P's class had a faster reaction speed than Mrs. A's class.
But which measure of central tendency should we use when looking at the two groups? I believe that using range as the measure of central tendency is the best option when working on an investigation like this. This is because the range shows us how consistent the class was and is affected less by outliers than something like the mean. This shows us the consistency of the class is more important because it allows us to see if all the students are about the same level or if they're all at different points. So when comparing two classes, we can compare the consistency to show which class can consistently be at a higher level rather than having some students be way lower and some students having much higher scores. In conclusion, we can see that in general, Mr. P's class performed not only better in most tests, but also was more consistent in most cases. However, there are some similarities between the two classes' scores, for example, the maximum and minimum scores in some tests.